Hello world, let's talk about F strings, which is short for formatted strings. So when we started learning Python, we probably learned to add strings together using the plus operator. For example, I'm going to create a name Tom and an age is 30, and I'm going to create a string is equals to my name is Tom, so plus name plus space, and my age is space plus stir age. And if we print string, we will get my name is Tom and my age is 30. So we probably learn how to add strings and variables together this way. However, as these strings become longer and more complicated, doing this will get super annoying. So I highly recommend learning how to use formatted strings, or F strings for short, in order to make your life less painful. Thus, here are 13 cool ways we can use F strings in our Python code. So first, let's start with the basic usage. So similarly, name is equals to Tom and age is equals to 30. So now let's create our string. Since we want our string to be a F string, we need to add a F in front of our string. And my name is name and my age is age. So notice that whatever variables I wish to add to the string are actually inside curly braces like name and age. Also, notice that I do not need to convert age to a string here, as it is automatically converted when it is in a formatted string. So I'm going to print X and let's check out what happens. And here we have it, my name is Tom and my age is 30. Number 2, displaying the variables name and value together. So let's say we have name is equals to Tom and age is equals to 30. And we wish to do some debugging. So we can do this. X is equals to F string. And here we have our curly braces. And in we put name equals and age equals. So if we print X, we are going to get this. So here we can see that name is equals to Tom and age is equals to 30. So here what's happening is that the name variable as well as the value of the variable name will both appear due to this equal sign here. Number 3, we can use F strings to round off our numbers to hexadecimal places. So let's say I have pi is equals to 3.14159.265. And let's say I want to add this into a string. So x is equals to F string. So pi is pi. So let's print this first and we will simply get, so pi is equals to 3.14159.265. However, let's say we want to round this off to 2 decimal places. So after pi, we can add a colon, a dot, and a 2f. So this 2f means 2 decimal places. So let's try this again. And here we can see that pi is 3.14. So if we want to edit the number of decimal places, we simply need to change this number over here. So let's say we want 5 decimal places. And here we have it, 3.14159. Number 4, rounding numbers to X significant figures. Let's say we have 3 numbers. A is equals to 3.14159, B is equals to 3.14159, and C is equals to 0.00314159. So now, instead of decimal places, we want to round off our numbers to significant figures. So here's how we can do it. So X is equals to F string, and let's put A, B, and C. So if we print X, we'll just get the numbers as per normal. However, let's say we want to round each of them to 3 significant figures. So after our numbers, we add a colon, a dot, and a number, and a G. So this is 3 significant figures. So let's do the same for B and C. 3G, colon dot 3G, and let's print. So here we can see that all our numbers has been rounded off to 3 significant figures. Number 5, aligning strings using spaces. So let's say I have a string apple and I want to pad this string with spaces either on the left, right, or both sides. So here's how I can do it. So let's print a F string and let's add these arrows to visualize it better. So we have X colon less than 20. So if we print this, we will get this string. So essentially, this syntax will create a string of length 20, and x, which is apple, will be on the left side. So let's do the same but for the right side. So instead of the less than sign, we use the right arrow, and we will get this. So notice on the first line, apple is on the far left, but on the second line, apple is on the far right. So similarly, this syntax will create a string of length 20 and with x, which is apple, on the far right. However, what if we want x to be in the middle? So here's how we can do it. So instead of using this right arrow, we use the upwards arrow. And once again, if we print this, we will get apple in the middle. So this trick can be pretty useful if you are thinking of creating your own tables using strings. Number 6, aligning strings using other characters. So previously, we learned that we can align and pad strings using spaces. However, we can also do it using other characters. So let's say we want to pad our first line using dashes. So we can add the dash right after the colon. And this is what we'll get. So notice that instead of spaces, we have a bunch of dashes right now. Similarly, let's add stuff here. So let's say we want to pad here with x. And we want to pad this using equal sign. And if we run this, we will get this. So in the first line, apple is on the far left, and it is being padded with dash, which is defined here. And in our second line, apple is on the far right, and it is being padded using the x character. And in the last line, apple is in the middle, and it is padded on both sides with the equal sign. Number 7, inserting commas into large numbers. So let's say we have a bunch of large numbers. So a is equals to this, b is equals to this, c is equals to this. And at first glance, we cannot really tell very quickly what these numbers are because of the large number of zeros. However, we can use f strings to help us here. So let's print f string a, b, and c. So right now, if we were to just print it normally, we are still going to just get these numbers. However, we can add the colon and a comma after it to each of these numbers in order to automatically add commas to these large numbers. And if we run this, we will get this. So here, at first glance, I can tell that A is 100,000, B is 1 million, and C is 10 million. So this is useful if we have many large numbers and we want to make stuff as readable as possible. Number 8, converting numbers to percentages. So let's say we have a bunch of fractions. A is 0.25, B is equals to 0.5, and C is equals to 0.75. So let's say we want a quick way to convert these fractions into percentages without having to do the math ourselves. So we can do it using f strings too, like this. So print f string a, b, and c, and after each number we can add a colon, a dot, followed by a number and a percentage. So let's do the same for b, let's do the same for c, and let's see what happens. So here, a, which is 0.25, will be printed as 25% with 0 decimal places, and b, which is 0.5, will be 50%. But here, the dot 1 signifies that we want to have 1 decimal place in our percentage, and that's why b is showing up as 50.0%. Similarly, for c, which is 0.75, we will get 75% after converting it into a percentage, but because of the 0.2, we signify that we want it to have 2 decimal places, and therefore it is 75.00%. Number 9, positive or negative numbers. So let's say we have a bunch of numbers that can be both positive or negative. Let's say a is equals to 12 and b is equals to negative 13. And let's say we want to explicitly show whether a number is positive or negative. So we can do that using f strings too. So print f string a and b. So to do this, we simply need to add a colon and a plus. So this colon plus here will enable us to check whether a number is positive or negative. So here, positive 12 becomes plus 12, and negative 13 will remain as negative 13. Number 10, showing raw output. So let's say I have a name is equals to Rocky, and let's print f string my name is open and close brace name. And if we do this, we will get my name is Rocky. However, sometimes during debugging, we wish to add the representation, so which is REPR, open bracket, and doing this will give us the raw output. So notice here, my name is Rocky, and Rocky here will be represented as a string. So for f strings, there's actually a shortcut for this. So instead of having to call the rep function, we can simply add exclamation mark R, and we will get the same result. Number 11, converting integers to hexadecimal. So let's print a bunch of integers, f string. So 1, 2, 3, 4. So let's have 9, 10, 11, and 12. So right now, we are just printing the integers. However, if we wish to convert them into hexadecimal, we can do so by doing this. So after each value, we add a colon, a hash, and a 0x. So if we print this right now, we will get 9, 10, 11, and 12, but in hexadecimal format. Number 12, formatting datetime. So let's just create a datetime first. From datetime, import datetime. And let's say D is equals to datetime. Let's say 2023 and 31st of December. So if we print D, we will get this long string. However, most of the time, we wish to format this in another format. So f strings do enable us the functionality to do this. So let's do this. F, my birthday is D. So if we do this currently, it will still be formatted normally. However, we can choose to add whatever datetime format we want after our datetime object here. So similarly, we have a colon, and afterwards we can add the datetime. So let's go with %B, %D, and %Y. So if we do this and we print this, we will get my birthday is December 31st, 2023. So right now, you might be wondering, how would we know what any of these symbols mean? So we can actually head on over to w3schools.com and we can find a bunch of symbols here. I'll put the link down in the description down below. So if we want to flip this over, we can. And let's say we put the year before, and let's put the B, which is the month later on. So right now, we have flipped it over. We have 2023, 31st December. So here we can do other cool stuff too. So my birthday is D, and let's say %small b, %d, comma, %big Y, and we have a bracket, and %a. And if we run this, we will get this. My birthday is December 31, comma, 2023, open bracket, Sunday, close bracket. So with the different symbols here, we actually have a powerful way of formatting our datetime using f strings. Number 13, binary numbers. So let's say we want a quick way to convert a number into binary. So we can do this using f strings too. So let's say print an f string. So let's create a bunch of numbers. So 1, 2, 4, and let's say 5. And to print them in binary, after each number, we simply need to add a colon and a B. So let's do the same for 2, the same for 4, and the same for 5. And if we print this, we will get the numbers in binary format. So thanks for watching, and I hope you have learned at least one new thing about Python today.